Hello everybody. Today I wanted to talk about the 30, 60, 90 special right triangle. The side opposite 90 degrees is called the hypotenuse. The other two sides are called legs. And what makes the 30, 60, 90 special right triangle so special is that if the side opposite 30 is t, the side opposite 60 is t root 3, and the side opposite 90, which is a hypotenuse, has length 2t. And so that means that if you're given one of the side lengths and you know it's a 30, 60, 90 special right triangle, you're able to find the other two side lengths easily. Okay, so let's go over some examples. In all of these examples, the instructions are going to be the same, so I'm not going to write it again and again. The instructions are find the missing side lengths. Okay, so let's start with a triangle like so. This being 90, this over here is going to be 30 degrees. This over here going to be 60 degrees. And we'll suppose, for the sake of argument, that the side opposite 30 is length 5. Okay, so the 30, 60, 90 right triangle tells us that if the side opposite 30 is 5, then the side opposite 60, which is right down here, is going to be 5 root 3. And the side opposite 90, which is the hypotenuse, is going to be 2 times 5, which of course multiplies to 10. So the longer side length is 5 root 3, and the hypotenuse is length 10. Okay, let's do another example. Let's suppose we have a triangle like so. And we'll say this is 30, this is 60. Unfortunately not quite to scale, but I'm sure you get the idea. And now let's suppose that the hypotenuse here has length, I don't know, we'll say 8. Okay, so because of this relationship, we know that if the side opposite 30 has length t, then the hypotenuse has length 2t, and the side opposite 60 has length t root 3. Okay, so that means this would be t here, and this would be t root 3, and this here would be 2t. Okay, so now we need to solve this for t. So we have 2t equal to 8. And of course you solve this by dividing both sides by 2. And we get here that t equal to 4. Okay, so that means that the side opposite 30 degrees would have to be 4, and the side opposite 60 degrees would have to be 4 root 3. Okay. Another example, let's say we have another 30, 60, 90 special right triangle. Let's see, this looks, I don't know, more like 30, still not to scale. And then we'll say this is 60. And this time, let's suppose, for the sake of argument, that this guy over here is, let's say, 10 root 6. Okay. Now, once again, we know the relationships here are that if this here is t, this would have to be t root 3, and this would have to be 2t. So let's go ahead and solve this guy for t. We have 2t equal to 10 root 6, and we go ahead and solve this by dividing both sides by 2, and that implies t would have to be 5 root 6. Okay, so that means that this here would be 5 root 6. Now this one here would have to be 5 root 6 times root 3. And then we know 6 times 3 is 18, so root 6 times root 3 is going to be root 18. Okay, now 18 is 9 times 2. So that means root 18 is the same thing as root 9 times root 2. Root 9, of course, is 3. Therefore, this is 5 times 3 times root 2, which is 15 root 2. Okay, and maybe I'll write the final result here in red because it was complicated. Okay, so this was 15 root 2, and this here, no. Okay, so this here was 5 root 6, and this here was 15 root 2. Okay, all right, let's try another example. We have a 30, 60, 90 special right triangle. We'll suppose this is 30 degrees. This is 60 degrees. And we'll suppose this is 7 root 3. All right, well, we know because of our relationship here that if this is t, this is t root 3, and this is 2t. That implies here that this is t root 3, this is t, and this is 2t. T root 3 equal to 7 root 3. That implies the t equal to 7. Therefore, the side opposite 30 degrees would have length 7, and the side opposite 90, which is the hypotenuse, would have length 2 times 7, which is 14. Okay, now let's do another one. Let's suppose we have something like the following. Okay, so we have a triangle like this, and let's suppose this here is 6. This one being 60 degrees, this being 30 degrees. Okay, so we know that the side opposite 30 degrees is supposed to be t. This is t root 3, and this is 2t. So what we need to do here is we need to solve this for t. So we have t root 3 equal to 6. And of course, the first step to solving this for t is dividing both sides by root 3. Okay, now we need to rationalize the denominator. You do that by multiplying the top and bottom by the square root of 3. And this is valid because root 3 over root 3 is 1. Okay, now 6 times root 3 is 6 root 3. And then by design, root 3 times root 3 is 3, which is a rational number. But then since 6 is 3 times 2, we have cancellation here, and we're left with a 2 here. We have 2 root 3 over 1. And of course, any number divided by 1 is simply that number, so this is 2 root 3. Okay, now let me go ahead and write this in a different color. So this would have to be 2 root 3. This here is 2 times 2 root 3. And because 2 times 2 is 4, that means this simplifies to 4 root 3. So the hypotenuse has length 4 root 3, and the side length here has length 2 root 3. Once again, hypotenuse 4, length 3. Leg here, smaller leg, is 2 root 3. All right, thank you guys so much for watching. Bye-bye.